Dear students, please open your textbook before you start listening. Underline important lines and mark difficult words. Use earphone or headphone for full concentration. Happy listening and happy learning. Subject Science, Chapter 5, page number 79. Periodic classification of elements. In class 9, we have learned that matter around us is present in the form of elements, compounds and mixtures, and the elements contain atoms of only one type. Do you know how many elements are known till date? At present, 118 elements are known to us. All these have different properties. Out of these 118, only 94 are naturally occurring. As different elements were being discovered, scientists gathered more and more information about the properties of these elements. They found it difficult to organize all that was known about the elements. They started looking for some pattern in their properties, on the basis of which they could study such a large number of elements with ease. 5.1 Making order out of chaos. Early attempt at the classification of elements. We have been learning how various things or living beings can be classified on the basis of their properties. Even in other situations, we come across instances of organization based on some properties. For example, in a shop, soaps are kept together at one place while biscuits are kept together elsewhere. Even among soaps, bathing soaps are stacked separately from washing soaps. Similarly, scientists made several attempts to classify elements according to their properties and obtain an orderly arrangement out of chaos. The earliest attempt to classify the elements resulted in grouping the then known element as metals and non-metals. Later, further classification were tried out as our knowledge of elements and their properties increased. 5.1.1 Dobernier's Tribes. In the year 1817, Johann Wolfgang Dobereiner, a German chemist, tried to arrange the element with similar properties into groups. He identified some groups having 3 elements each, so he called these groups triads. Dobernier showed that when the 3 elements in a triad were written in the order of increasing atomic masses. Page number 80. The atomic mass of the middle element was roughly the average of the atomic masses of the other 2 elements. For example, take the triad consisting of lithium Li, sodium Na, and potassium K with the respective atomic masses 6.9 and 23.0 and 39.0. What is the average of the atomic masses of lithium and potassium? How does this compare with the atomic mass of sodium? Given below, table 5.1 are some group of 3 elements. These elements are arranged downward in order of increasing atomic masses. Can you find out which of these groups form Dobereiner's triads? Table 5.1. In table 5.1, 6 columns are given. Please look at the screen. In first group, group A element, second column, atomic masses, third column, group B element, fourth column, atomic mass, fifth column, group C element, sixth column, atomic mass. You will find that groups B and C form Dobereiner's triads. Dobereiner could identify only 3 triads from the elements known at that time, table 5.2. Hence, This system of classification into triads was not found to be useful. John Wolfgang Dobereiner's 1780 to 1849. John Wolfgang Dobereiner studied as a pharmacist at Münchberg in Germany and then studied chemistry at Strasbourg. Eventually, he became a professor of chemistry and pharmacy at the University of Jena. Dobereiner made the first observation of platinum as a catalyst and discovered similar triads of elements which led to the development of the periodic table of elements. 5.1.2 Newlands Law of Octaves. The attempts of Dobereiner encouraged other chemists to correlate the properties of elements with their atomic masses. In 1866, John Newlands, an English scientist, arranged the then known element in the order of increasing atomic masses. He started with the element having the lowest atomic mass, hydrogen, and then ended at thorium, which was the 56th element. He found that every eighth element had properties similar to that of the first. He compared this to the octaves found in music. Therefore, he called it the law of octaves. It is known as the Newlands Law of Octaves. In Newlands octaves, the properties of lithium and sodium were found to be the same. Sodium is the eighth element after lithium. Similarly, beryllium and magnesium resemble each other. A part of the original form of Newlands octaves is given in the table 5.3. Page number 81. Table 5.3. Newlands octaves. Please see on the screen and page number 81. In column 1 table is given. There are seven columns. Note of music. Now the column Do you know? Are you familiar with musical notes? In the Indian system of music, there are 7 musical notes in a scale. Sa, re, ga, ma, pa, da, ni. In the West, they use the notations do, re, mi, fa, so, la, ti. The notes in a scale are separated by whole and half step frequency, interval of tone and semitones. A musician uses these notes for composing the music of a song. Naturally, there must be some repetition of notes. Every eighth note is similar to the first one and it is the first note of the next scale. It was found that the law of octaves was applicable only up to calcium. As after calcium, every eighth element did not possess properties similar to that of the first. It was assumed by Newland that only 56 elements existed in nature and no more element would be discovered in the future. But later on, several new elements were discovered whose properties did not fit into the law of octaves. In order to fit elements into his table, Newlands adjusted 2 elements in the same slot but also put some unlike element under the same note. Can you find examples of these from table 5.3? Note that cobalt and nickel are in the same slot and these are placed in the same column as fluorine, chlorine and bromine, which have very different properties than these elements. Iron, which resembles cobalt and nickel in properties, has been placed far away from these elements. With the discovery of noble gases, the law of octaves became irrelevant. Thus, Newlands' laws of octaves worked well with lighter elements only. Now questions. Question number 1. Did Dobereiner's triads also exist in the columns of Newlands octaves? Compare and find out. Question number 2. What were the limitations of Dobereiner's classification? Question 3. What were the limitations of Newlands' law of octaves? 5.2. making order out of chaos. Mendeleev's periodic table. Even after the rejection of Newlands Law of Octaves, scientists continued to search for a pattern that correlated the properties of elements with their atomic masses. Page number 82. The main credit for classifying element goes to Dmitry Ivanovich Mendeleev, a Russian scientist. He was the most important contributor to the early development of a periodic table of elements, wherein the elements were arranged on the basis of their fundamental property, the atomic mass, and also on the similarity of chemical properties. Dmitry Ivanovich Mendeleev, 1834 to 1907. Dmitry Ivanovich Mendeleev was born on Tobolsk in western Siberia, Russia on February 8, 1834. After his early education, Mendeleev could join a university only due to the effort of his mother. Dedicating his investigation to his mother, he wrote, "She instructed with example, corrected with love, and travelled with me to places spending her last resources and strength. She knew that, with the aid of science, without violence, with love but firmness, all superstitions, untruth, and error can be removed." The arrangement of elements he proposed is called Mendeleev's periodic table. The periodic table proved to be the unifying principle in chemistry. It was the motivation for the discovery of some new elements. When Mendeleev started his work, 63 elements were known. He examined the relationship between the atomic masses of the element and their physical and chemical properties. Among chemical properties, Mendeleev concentrated on the compounds formed by elements with oxygen and hydrogen. He selected hydrogen and oxygen as they are very reactive and formed compounds with most elements. The formulae of the hydrides and oxides formed by an element were treated as one of the basic properties of an element for its classification. He then took 63 cards, and on each card he wrote down the properties of one element. He sorted out the element with similar properties and pinned the card together on a wall. He observed that most of the elements got a place in a periodic table and were arranged in the order of their increasing atomic masses. It was also observed that there occurs a periodic recurrence of elements with similar physical and chemical properties. On this basis, Mendeleev formulated a periodic law which states that the properties of elements are the periodic function of their atomic masses. Mendeleev's periodic table contains vertical column called groups and horizontal row called period. In table 5.4. Page number 83. Table 5.4. Mendeleev's periodic table. In this table, Mendeleev's periodic table is written. Please see on the screen. It is well described there. There are 8 columns. Mendeleev's periodic table was published in a German journal in 1872. In the formula for oxides and hydrides at the top of the column, the letter R is used to represent any of the elements in the group. Note the way formulae are written. For example, the hydride of carbon, CH4, is written as RH4 and the oxide CO2 as RO2. 5.2.1 Achievement of Mendeleev's periodic table. While developing the periodic table, there were a few instances where Mendeleev had to be placed an element with a slightly greater atomic mass before an element with a slightly lower atomic mass. The sequence was inverted so that elements with similar properties could be grouped together. For example, cobalt, atomic mass 58.9, appeared before nickel, atomic mass 58.7. Looking at table 5.4, can you find out one more such anomaly? Further, Mendeleev left some gap in his periodic table. Instead of looking upon these gaps as defects, Mendeleev boldly predicted the existence of some element that had not been discovered at that time. Mendeleev named them by prefixing a Sanskrit numeral Eka in bracket 1 to the name of preceding element in the same group. For instance, scandium, gallium, and germanium, discovered later, have properties similar to Eka boron, Eka aluminum, and Eka silicon. Thank you, students. Please listen twice for better understanding. Hope you liked the video and subscribe for upcoming videos.